machines. I will actually start from scratch. So we have, we will go through running your large language models locally on your PC or whatever device you have. And then we are going to go to use MCP for integrating it with real data from the outside or living in tools to actually interact with the real world. So that's what I just said. You will hopefully learn these 3 things. And then let's start. So I personally had the greatest experiences with these 2 tools, so Ollama and OpenWebUI. And we need these 2 to once have the models running, so have some interface with the models, putting them on the GPU and then executing it. And then we also want to have a nice web user interface instead of typing it in a terminal, because then we get lots of beneficials, like also having it visually. Yeah, starting with Ollama. This is primarily a CLI tool, and it builds on top on Llama CPP. Yeah. Maybe some of you who did very early testing with large language models use Llama CPP. This is basically a tool which provides you a server where you can run your large language models, but it's, as the name says, written in C++ and C. So it's a bit low level and more technical, and therefore Ollama is, for me, at least the way to go. Because there you can really simply build on top on. The models are frequently updated, you can download them very fast. And it's also very, very simple to install. So you can also install it via Python or whatever you like, but I think Docker is the best way. It's just one command and you have it running on your local machine. This is the command, so whoever wants then to try it out afterwards, looking at slides, this is the command for if you have a GPU from NVIDIA. There's also, if you go to the documentation, you can find all the other installation guides.
Also, it works with AMD. I got to work like a year ago, but a year ago it was a pain. So.
I think it still is a pain, but it works. Yeah. Then OpenWebUI. Then we have, now we can run the models locally, and now we want to have an interface to actually use it. Ollama provides a CLI, but that's not that user-friendly for most people. So we have OpenWebUI, which was also previously called Ollama WebUI, because it was basically built for Ollama. Therefore, it's also very simple to set up. You just go for the same approach. Yeah, that's how it looks like. You also set it up in Docker, and then you have this web interface. And if you have the Ollama instance running and exposed on your local host, then it will also automatically connect to it and you can start using it. Then the only thing that we're missing is an actual model. So where do we get this from? I suppose if someone is not a machine learning engineer or wants to spend countless hours on it, the best approach is actually the very laziest one, is the lower one. Just go to the Ollama search and see what other people download, and probably it's good for you. Or if you're a bit more experienced and you want to check out a model that fits your use case, because actually models are really depending on the use case, especially small local models. Then they can't really do as much as the big ones, you know, like from the OpenAI models or the Google ones, the Cloud ones. They can't do as much as them, so we need to specify what we want to do. And yeah, this is on Ollama, and this is the benchmark, so the second link, where there's actually categories where you can find the best models. You can also filter on local models, open source models, and open weight models here. Of course, the leading models are as well proprietary models. There are some rules of thumb which you can consider when downloading your first model. If you're not sure if it fits on your GPU, you can always think about it. If it has like around 7 billion parameters, usually in the name there's a 7B written somewhere. It fits into 8 GB VRAM or unified RAM if you have a Mac, or around 13 billion parameters. You will get along with a 16 GB VRAM That's, for example, these are the biggest affordable consumer GPUs, I would say. But you can reduce this a lot actually by making quantization. That you can usually see if in a model name you see this Q4 or Q8. This means that the model is actually reduced since they are always computed in float 16, so 16 bits floats, and this reduces them down to 8-bit or 4-bit integers. And that actually turns out is very efficient. For the 8-bit one, you get a reduction of 50% and a speed up of 1.56% roughly. But that's not where it stops. Actually, 4-bit quantization turns out to be the most efficient one because you end up with just a quarter of the size. And in many, many cases, there is a loss of quality less than 1%, so it's really not much. And a speed of 1.4. And at the very end, you always need to download a few models and check what fits your work and use case the best. So we now have Ollama, the tool to run the models, interface, which is WebUI, and the large language model. So I can start with the cool part, which is the model context protocol. So this is actually quite new. When I first sent to Stefano that I want to make this talk, it was actually very, very new. I did not know if it will be a thing or not. It actually turned out it will be a thing. So many, many companies are adopting it. There are many servers out there you can connect to. But what's the need of it? It's actually built for interacting with the real world. So before there was a standardized protocol, people had to create custom scripts for the large language model interacting with the real world, for example. And one of the first ones was that ChatGPT was using Canva, so this design tool. There I had to do a custom implementation, and for every tool you had to do this again. That's maybe feasible for a big company, but even then it's a mess. And for individuals, it's just not doable. So then Anthropic, the company behind Cloud, the Cloud was like the Sonnet and Opus models, they introduced this model context protocol. There's also other protocols in this field, but this turns out to be the most relevant one. The basic structure is a client-server pattern. So you have on the host machine, you have your clients. Actually, one host can have multiple clients. So for us, our Open Web UI would be a host, and there we can have multiple clients, which always have a one-to-one connection to a server. Then a server can actually be on your local machine. They are usually connected with standard I/O. So this is very useful for example, accessing your file system or executing stuff on your own PC, because there's low latency with standard I/O. But there's also remote servers, which can be everywhere, and you connect them via HTTP, and they connect to databases or other REST APIs. Whatever you want. Whatever is accessible in the internet, you can connect to it. And actually, the local MCP server, so the one where you connected with standard I/O, they are very, very strong at the beginning when MCP came out. But right now, not so many people are using it. Most people switch to HTTP, even on the local machines. What are primitives? So MCP protocol, they introduce quite strong primitives. They are being predefined ways to interact with the server. So the server can provide them, and these are the following. If you connect to one, you can either use tools, so on the top left. This is actually the most used ones because they are the most powerful ones. You can basically teach your large language model or tell them what it can do, what the parameters are of a given function of whatever you want to achieve, and then the model can decide on its own if it wants to execute this function or tell the client to actually execute the function or not. Then there are prompts, which are provided by the server, but then handled by the user. So the user has to see the prompts and actively decides, I want to use this prompt. So prompts are like standardized templates, which allow you for easier prompting. And the last one is resources. This is handled by the client, so not by the model, not by the server, but by the client. And you basically say the model what he knows. So you give additional context. It's basically the same as you would just write additional prompts in there, but in resources. This you can think of the most about making GET requests from an API or a database, and then you provide this additional information, but by your own, not the server, not the model doesn't. Then this is the architecture. So if we actually want to use the protocol, there are these 3 and 4 steps. First, there is a handshake between the MCP client and the server it wants to connect to. It basically says hi, and there, like most other protocols, do the same. And as soon as the connection is established, we can do discovery. So then the client can go to the server and check what tools, what resources, what prompts are there. And afterwards, it can decide what to execute. This would be so between second and third step, a user would typically enter a prompt, and then the client will execute either a tool, a resource, or a prompt. And what's also very, very nice, so the fourth point is the real-time updates. So the client will know if something on the server changes without calling the server over and over again. That's quite handy, but yeah, not the most often used one. So now we know what MCP is, how it kind of works, but we want to work on our own one. In this case, we can use the provided SDKs. So Anthropic really did a great job on developing these SDKs. They are all MIT licensed, and in all major languages there is one SDK. And right now I've chosen to use the Python one. So you can simply input everything, so especially the fast MCP server. And that's actually everything we need to set up our own MCP server. Of course, it's not in the packages, but that's it. And where there is the placeholder, we can now add our function, so whatever we want to call. Here I decided to use a tool, and that's a very cool part about it. Over there. This is some example I came up for today. Basically, we define our function name up here, which you can call whatever you want. And this string is actually where the magic happens, because there you can tell in a structured way the model what this function can do. So this is the upper part. Then you also describe what the arguments are. In this one, it's just a message that it worked. And if we read through what the function says, it's basically a helper function for me as a lazy presenter to help me navigate my slides. And then at the very end, it also returns a message that it did work. Everything below is just Python code. You can do whatever you want there. You can also integrate your apps that you already created, you've been working on it, and just creating one of these tools so a client can access it. And that's a special case for the Open Web UI, because they somehow decided to not use the normal MCP implementation, but they put an additional wrapper around it, which is actually quite handy because you don't have to worry about standard O or any other provided protocols. You can simply run everything with HTTP, and also they will generate open API documentation about it, which you can also look at in Swagger. So that's very handy for also as a person to look at the things the server can do. So we can actually test this out. Let me just start the demo. So what we do, we are going to start our server, like we just saw on the slide, and it should work fine. Then we can go to our instance, which we also learned already, the instance of the Open Web UI. There we go. You can see the tool is active. It's actually very simple to do that. I'll show it in later slides. And now we can, I wrote it somewhere, there we go. We can tell the model that I'm very lazy in presenting. Please take over the task of going to the next slide and do that in the next 5 seconds. So we can actually do that. So the first time we are going to use our large language models, it will have to load it into the GPU. So this will take a while. But it's only the first time as we need to load everything to the GPU. And there we go. Let's get back in here. If you too slow. And then, if it did work, it should go to the next slide. Let's see what it does. Oh, it does what we were. Do it again. Let's see. So, it's got me right this time. Okay, should we check again? Okay, don't know what's happening here. Yeah, it seems that something broke. We just try it again. And then if not, we just do it ourselves. There we go. It was not me. That's it. That's basically how we set it up. I did a mistake because that should be the slide where the I should cut. So basically, we can see that with this very simple program, we were able to just chat with the model, and it did something on my PC. It's quite nice. And now we can actually go to the real demo, which is an integration of the Open Data Hub. So what I did there was that I created a few more functions. Let me know if it is readable, right? Even from behind?
Yeah.
Okay, great. So what we did here, these are helper functions. We are connected to the Open Data Hub, and down there we created some tools which interact with the API. For example, this one gets a list of events from the Open Data Hub API formatted as Markdown. This is actually one thing that helps the model a lot. If we could also just provide them the data as it is, but it turns out if we do a little bit more effort to actually structuring the data in a bit of a nicer way, we'll get way better results. There are a few more tools. So there's one tool which retrieves a list of available station types on the APIs of the Open Data Hub, like bicycle, bike counters, etc. And yeah, we can also get station types here and get also the latest data from it. So if we just close this again and start our, so we still use the same code, so we don't have to do anything on Open Web UI, but we are just starting another server where we can connect to. And here, maybe what's nice to see is also in the browser.
Could I ask?
Yes.
Something? How did you connect Open Web UI with the MCP server?
Yeah, exactly. Sorry, I think I moved too fast there. Let's get back. Here's the setup on it. It's very simple. You can just do it in the settings. you basically specify the port and the address of it, and it will connect. Also, what's very handy about it is that you can also use like beer tokens or any other authentication system there. So you can also host your MCP servers and actually restrict access to it, but accessing it through OpenWebUI very simply. So there we go. The tool is now loaded. You see it in here. This is what it says. It's not that nice to look at, so maybe it's better to go to the browser. So this is also what the server generated by itself. We can see these are post requests because everything which we specify as a tool will be a post request. On the other hand, resources will be flagged as GET requests, but tools are way more powerful. Yeah, that's all that was generated for us. Then let's see. Let's try it out. Let's see. What's our So you just asked very kindly what are upcoming events based on the Open Data Hub, and see if the model figures out what to look at. And we see it was able to actually figure it out. Down there we can see which tools it was using. There's again events post, access, request, and there we can also see the formatted data. So this helps the model a lot instead of using just the JSON. You can just use the markdown files, and then yeah, maybe we are getting the ones with 1 and 0 at the beginning because we are the first few entries in the list. But maybe we also want to see what stations are available on the Open Data Hub. Maybe we can see to integrate some mobility data. We're just chatting. We don't know actually what's in the Open Data Hub, just testing it around. So you can see the model is loaded, so it's very fast. And maybe I know that bike sharing, maybe bike sharing station, there are some, and I would like to find a bike sharing station near one of the events. So let's say it's Koch. Maybe there's none near, so you have to set the radius very high up, but let's see. So let's say that I'm really interested to this event and see if there's anything near it. And I want to bike there. Okay, let's make sure we really get some stations and put it like 100 kilometers. Yeah, the top 5 ones, so we don't get too many. And then with the description of the API, it should actually be able to understand to use the parameters. Oh, and we actually received one few, and we see, and it was able to set the limit to 5, which is set the only one top 5 ones, and using the distance less than operator with the coordinates from the data we got before to get these bike sharing stations. So I think that's quite cool. We can really interact with natural voice or natural text with the Open Data Hub. which is otherwise not the case, obviously. You have to look into the OpenAPI specifications and get an understanding what's in there, and this job does the model for you in this case. And yeah, that's it for the demo. And there's not much to say more. So we talked about how to set it up. We were able to run it, and that's it. Thank you very much.